Good afternoon. Welcome everyone to our final series of sessions today. It's been a long day at the conference, but I hope you've gone to take in some great after-school specific best practices. My name is Andrew Ganishow. I am Director of Louisiana After School Network, and I'm pleased to welcome you to this final session. I want to remind you, this is a CEU session, thanks to our partnership with the College of Education at Louisiana Tech University and their science and technology sessions. We are able to offer CEU credits for these series of sessions, as well as the 2 sessions tomorrow morning, which I encourage you to check out: the If Then collection, a STEM diversity workshop, as well as youth entrepreneurship with the Youth Entrepreneurship Institute. Those are CEU credit sessions as well. But today we're going to focus on a big part of this conference planning is the planning committee, and a big recommendation we received was fun math, fun and engaging ways for math activities. So we reached out to the team at Jump Math, and I'm now going to turn it over to them. John, can you present us some fun, interesting way for math? Are you there, John?
John, you're on mute.
Sorry, there we go. Thanks so much. So Lynn is also on the call, Lynn Stratton from LA Tech, and we'll be presenting today. We hope to have a lot of participation from people. I'm a mathematician, but I struggled in math when I was young. I almost failed calculus at university. I barely made it through. And I only went into math in my 30s and got the confidence to do math in my 30s. And I've worked with thousands and thousands of students, some who really struggled. One of my first students was in a remedial grade 6 class, and his mother was told that he could never learn math, that he was too challenged. And 2 years ago, we went out to celebrate the fact that he's now a fully tenured math professor. So, you know, I've seen so many kids move from remedial stream to academic, and I have really, really strong views that everyone can learn math. And we're going to try and demonstrate a bunch of activities today to make, you know, to give you some ideas about how you can engage every student and get every student really excited about math. Maybe Lynn, if you want to introduce yourself.
Hey guys, I'm Lynn Stratton. I'm a professor at Louisiana Tech University in the College of Education. I teach all of the math methods courses. And so kind of in a nutshell, like John gave you, I was trained to be a secondary math teacher. I did not like math at all as an elementary student. And I learned later it was the computation that I didn't enjoy. Once we got into algebra and no longer had to deal with computation and got to go into variables, I was pretty happy. And interesting, like life does for us sometimes, I took a shift when I had children. And I know that because of having my own kids and being so interested in how they developed mathematical reasoning and understanding, that I got extremely interested in that. And now all my work is at the elementary level for the most part. So I kind of have a similar story. In elementary math, I was not successful. I thought I wasn't smart. It was just a struggle for me, but then I liked it. And then here I am. I also have like a lot of math experience now, and that's my focus of my work. So I'm so happy to be here and glad you guys were willing to give some time on a Friday afternoon.
And so I hope you guys don't mind participating. Lynn, I think there's about 17 people in the group. I mean, do you think people might introduce themselves, because it would be great to have,
Sure,
you know, just quickly say hi and maybe say what grades you're teaching or what your interests are.
Some of them, John, just so you know, some of them are not in good speaking, so they can put it in the chat as well. Just, you know,
perfect.
Name,
yeah,
organization. We've been doing that today too. So if you have
that's
access
a great idea.
to the chat, just go ahead and type in your name and your organization.
Yeah, that's a great idea. So if you guys wouldn't mind typing in, and we'll be asking lots of questions through the talk, and you know, please feel free to use the chat, and or if you feel comfortable turning on your mic, that would be great too. So what we're going to do is start with a very brief introduction, and then going to start some exercises. We're going to look at how to make mental math fun, how to help kids learn number facts, how to help kids use their knowledge and understanding of math to make discoveries on their own. We're going to look at problem solving, look at some of the research on how kids learn and how you can apply that in the classroom. So Lynn, can you see the chat? Is that?
Yes, I do see the chat. There's
So
also
I have a
one person
question
in the waiting room.
from Ms. Whitaker. Have you taken some PD at LA Tech? You look familiar. Is that Lynn? I think Lynn is. I've done some talks there, and Lynn is an instructor at LA Tech.
Yeah, I wrote that and asked Miss Whitaker, have you done some training there? Because you look so familiar to me.
No, but my sister has.
Maybe it's her. Because I looked at you and went, oh my goodness, I know her.
No, my sister has. I have a math background and everything. I'm at Crestwell. I teach second grade. I'm going to be moving to fifth grade next year.
Oh, that's quite a jump.
Well, I used to teach fifth grade all the time. I just moved down, now moving back up.
I really appreciate people typing in the chat. It really helps us. So I see we've got some grade 5 teachers, grade 2 teachers. I love being in a room with people, so it's sometimes hard to connect over the screen. So the more information you give us in the chat, the better. So I'm going to share my screen now so I can show some slides. And we'll be showing some videos through this session. Can everybody see the screen okay? So just going to start my slides. So the material we're going to be presenting today is based on my experience and Lynn's experience in the classroom, working over many years. But there's quite a bit of evidence behind what we're talking about. So I was invited to give a keynote at the Aspen Brain Forum, which was a real honor. I was invited by cognitive scientists to speak about our results. And I also wrote an article for Scientific American Mind. So everything we're presenting today is based on some very solid research. Jump Math is a core program in Louisiana. It's a tier 1 resource that's being used in a number of districts, especially in the north. So we have teachers' resources, student books, and also smart interactive slides, and we're in the process of digitizing the whole program. Right now, a lot of these resources we're going to talk about today are free. And so if you have any interest in downloading some of these resources, you can just go to the Jump Math website, just type in jumpmath.org. And you'll have a choice to go to the US site or the Canadian site. I'm a Canadian. I hope you can understand my accent. But we're working in Louisiana in a number of districts. And if you just put in you can log in and create an account on the website. And once you have an account, it's free. You can go to Get Jump. You see at the top of the page there, and you can choose a teacher's resource for any grade you want. If we have time at the end, I can show you. I can walk you through how to navigate the website. But we have tons and tons of lesson plans, Blackline Masters, and confidence building exercises, and that cover the full curriculum from K to 8. So if you are interested in exploring the teachers' resources, you can see them there. One thing, if you go to the introduction of all the teachers' guides, you can find a section on mental math, and we're going to be demonstrating some of the exercises and activities for mental math today. There's a ton of research suggesting that kids become much better problem solvers if they have a good grasp of numbers and their relations. And so there's some really fun way for kids to learn their facts, to learn to do calculations and so on. And we'll be looking at some of those today. So, I think what we're talking about today is really important because for young kids, I'm going to move this down. Andrew, there's someone in the waiting room I've been trying to admit, but every time I try to admit them, I don't think it works. So I'm not sure if
Yeah,
I'm being
I've
fully.
been having that issue too. But I think they're already in. Is that it looks like it's Phil Marion, and then there's P Marion 110. So I want to be
Oh,
sure,
okay.
Phil, if you're trying to get in through two different avenues, we can't get in through P Marion 110, but I see Phil Marion. I think it's the same person. So
Okay, great. So, so the research is suggesting that for young students, that math success is a stronger predictor of success at school than even reading, um, you know, attention skills. Math for young kids, there's been these huge longitudinal studies that suggest that math is a huge predictor of success at school. It also, predicts what kind of career you're going to have, what kind of job you're going to get. A lot of people think, well, I got by without math. And I felt that for a while too, because I struggled in math. But the research is suggesting that, it's critically important that kids learn math. It becomes a barrier to later success and really drives a lot of kids to give up at school if they struggle in math. So Lynn, please jump into, I'm sure you've seen the same thing with your students.
Absolutely. In fact, I teach mostly well, kindergarten through sixth grade, teachers that aspire to be kindergarten through sixth grade. Although in the summer I do a lot of professional development, but unfortunately, many times I find that students want to become teachers because of their math anxiety. And they made that choice in many cases because they thought they didn't have to take as much math. And it's heartbreaking to me to know, like, of course, you've got your folks that are, have a service heart and want to teach children, and that's their first choice. But unfortunately, many say, well, I decided to do it because it didn't require a lot of higher level math.
Yeah, and the important thing in this session is we don't judge anyone, because I struggle in math, even though I'm a mathematician now, and I assume everyone can learn math, and if you're not learning, it's my fault. If a student isn't learning, it's something the teacher needs to do. It's not the student's problem. So I hope you won't be embarrassed to participate today, or even to make a mistake. Uh, I make mistakes all the time in front of kids, but I think it's critically important that we get rid of this idea that you have to be born with ability to do math. And we have to help teachers reduce their anxiety around math. And so that's one of the reasons I started the JUMP program. Even though I'm a mathematician, JUMP is a charity. It's growing very quickly in Canada and the US, and it's based on evidence. And our mission is to really help every student believe that they can do math. And I want to try and demonstrate, a lot of people think that algebra, there are things that are really inherently hard. I'm going to show you a video of an algebra lesson later with grade 4 kids, where we try and connect it to things the kids would be interested in, and the kids have an awful lot of fun in the lesson, and they all learn by the end of it. So one of the expectations in JUMP is that every child should be able to learn the math. And if they're not, then you need to modify the lesson and really find out why they're not doing it. So before I start, like I told you, I have pretty strong views about math and math ability. So before we start, I just want to show you one study we did in Canada. I don't know how many of you have teach grade 5. I also, in the chat, if any of you are ever lacked confidence yourself in math, or ever felt that you weren't born with ability, or you weren't born to do it, that was the case with me. If you had any insecurities about math, you feel free to share them in the chat. If there's anything that's not clear today, it's my fault, or it's our fault, not your fault if it's not clear. And so please say so in the chat, or turn on your microphone and say so. So this is a study. This red curve shows, it's a bell curve that shows the distribution of marks in a grade 5 class. It wasn't a big class, but we put in the bell curve just to show what it would look like. The mean mark on these test of achievement was in the 54th percentile, and there were kids as low as the 9th percentile, and then kids as high as the 75th percentile. And that would represent about a 3 grade level difference between the top and bottom students. So I'd like to start by asking a question. In your own classes or in your own schools, is that something you're seeing? Would you say that you by grade 5, there could be a 3 grade level difference between the top students and the bottom students? Is that a fair thing to say? So I'm gonna see if I can scroll through and see some people. If anyone wants to turn on their screen also, are you guys seeing by grade 5 or so a gap starting to open up between the kids? Is that fair to say that by grade 5 you could see a 3 grade level difference between students? And is this something that you might be struggling with in your own schools in trying to close the gap between students? So I'm just going to check the chat too if you are comfortable adding there.
Definitely a couple of people are seeing that. And I know that we're seeing it in schools that I work with often.
Mhm. So, one of the themes today is what can you do about that if you've got that kind of gap between kids? We think in JUMP, one of the reasons this gap opens up because, as early as grade 1, kids can start to tell if they're in the strong group or the weaker group. There's research that suggests that kids can tell if a teacher has different expectations for them, even in grade 1. We have a kind of radar for where we are in a pecking order. We can rank ourselves very easily. And even if it's a great teacher, kids can sometimes tell. And what happens to a student who decides they're not in the strong group? We found in our studies that they stop engaging, they stop really remembering things, they stop working. And so these gaps become bigger and bigger because once kids start to fall behind, it really affects the way they learn. So the question is, do we have to put up with this in our schools? Like, is this something we just have to accept that math is going to be hard for some kids, that there's always going to be this 3 grade level difference by grade 5? So this teacher used the methods that we're going to present today for a year with real fidelity. She followed our free online teacher's guides for a year. And this was, I'm going to show you a graph. It's a bit unbelievable, but it was reported in the New York Times. It crashed our website because it got such a big response. A year later, when she retested the kids, this is what the bell curve looked like. It was a spike at the 98th percentile. The lowest mark was in the 95th percentile. And then a year later, all the kids wrote the Pythagoras math competition, and all but 3 got awards of distinction. So that's the kind of potential that's in kids. Even by grade 5, even if they've struggled, it's possible to catch them up. And imagine if we had a whole society where kids were enjoying math, loving math, learning it, and where all kids could move together. Sometimes people say, well, we can't really take care of the weaker kids in a class because we'd have to slow down and the faster kids would suffer. They would be they would be bored or wouldn't move as far. But look at the data here. The weakest kids outperform the faster. All of them outperformed what they were doing a year earlier. No one was held back. Everyone moved further together. So this is a radical new approach to thinking about math. It's not based on the idea that kids are different in their abilities, that you can't move kids together. It's based on the idea that it's our problem as teachers and the school system. This is where the problem is. It's not with the students. They could all be performing at a very high level. I mentioned that I took a student from remedial level to doctoral level. Like, that's the potential in children. And it's a tragedy that we are not letting them realize their full potential, not only to learn math, but to love learning math, to enjoy making discoveries, making connections, to be drawing on their own knowledge and understanding to take things further. So it's a tragedy that this is happening, and what we're going to look at today is what we can do about it. So Lynn, I don't know if you want to add anything there.
I don't have anything for there.
Okay,
Other
great.
than I agree.
Yeah, okay, great. That was just a case study, but we saw similar results in a randomized controlled trial. This was funded by the US Department of Education. It was a very large randomized controlled trial. And on the right, you can see the white box and a black box. The black box is jump, and this was in problem solving in grade 3. In the second year of the study, the jump students made significantly more progress in problem solving than the control group, which is shown in the white box. You can see the difference in the levels of the two boxes on the right. So we've seen these incredible changes even in much larger rigorous studies, and these incredible speed ups in learning. So today, these are going to be kind of 4 of the themes today. There's a lot of research suggesting that these 4 principles are very effective, and we're going to illustrate them today. One is you have to start at the right level with the student. You have to be able to assess where they're at and start there. Another very powerful principle is of effective instruction is try and connect the math to something that's familiar or engaging to the student. Let them draw on their own knowledge and their own experience. And also there are sometimes natural ways kids tend to start thinking about things. And it's good if you know how to develop the math in a way that makes sense to kids and that can draw on their own understanding. We're going to talk a lot about the use of scaffolding, how to break challenges into more manageable chunks. There's research showing that we spend a lot of time in a state of cognitive overload. Our brains are constantly being overloaded in math class. We're not given enough time to consolidate ideas, to really practice and to get used to things, to explore things. And so it helps if teachers know how to scaffold the math and create a series of challenges and exercises that help kids move forward. And the final thing is we're going to look at how to build excitement. Carol Dweck, who wrote the book Mindset, is a fan of jump, and she said that in jump classes, we keep kids in a zone where they can struggle productively, where where they can extend themselves, where they can take a risk, where they can try something new, but where they're not afraid to do so. And so we're going to talk today about how you can keep kids in that zone, especially when they're not confident. Talk about how to build confidence using math. So Lynn, you're really an expert also in connecting math to kids' understanding, and I think that's a big theme in your research and the work you do at the university.
Yes, the work I do really focuses on how to take what a kid knows already and use that information to move them to the place where we know that we want them all to be, which could be any learning goal that we're thinking about. And if it's perfectly with all the brain research about how to connect, we know that children come to us at school with just a wealth of rich mathematical knowledge from experiences they've had at home. We have to figure out how to tap into that experience and how to move them like through the scaffolding through a very modeling perspective all the way to where the kid's able to solve the problem using complex relational ideas. And so I think that in reading, teachers have had that they've had that framework for quite a long time. And what I like about is that this gives us a way to think about that mathematically, how to figure out where kids are, where we want them to be, and how are we going to get them there.
Yeah, and so one thing we'll sort of demonstrate today is that pathway, how to get them there, and how to get them there with variations that are small enough for them to actually do the thinking. Like the teacher shouldn't be doing all the thinking, the kids should be, but the kids need guidance in doing that. They need some kind of scaffolding and guidance to make those discoveries or to connect what you're doing to their own experience. So that's what we'll be looking at. So I thought we would start with a little exercise so we're not just talking theory. And I hope you guys as participants wouldn't mind just taking a piece of paper and a pencil, if you could, so you could jot down some ideas. So here's a kind of a little exercise or challenge. And this might seem quite trivial, but it's phenomenally important. I've used the methods that I'm just going to talk about now like I said, to take many students, including groups of students, from remedial into academic stream. We had a school in Manhattan on the Lower East Side in a very poor neighborhood that got the greatest gains on the New York State tests of all schools in Manhattan, of all schools in New York City, including Brooklyn, the Bronx, everywhere. And the teachers use these techniques to make that happen. They had a massive gain, about a 30 percentage point gain on the state tests the first year they used it. And the teacher wrote a blog for Achieve the Core saying the kids wouldn't stop doing math. They just want to do math all day. And people think math is a boring subject or, you know, a intimidating subject. But we want to suggest how you can make math actually fun and less intimidating. So we'd really beg you to think about this and really extend yourselves. I'm going to ask you what sounds like a very trivial question, but it's fundamentally important. So suppose your students understand how to add a quarter plus a quarter. You know, they could demonstrate with a picture why it works. You have one piece out of 4 and one piece out of 4. When you combine them, you're going to have 2 pieces out of 4 or a half. But suppose your kids have got that and you want to challenge them a bit and get them excited. So our question is, could you think of several ways to modify this question so it looks harder, but it's not harder? It will look harder to the student, but it's not really harder. It's just a simple extension, and they can solve it using what they know. They can extend their thinking on their own. And you might, if you come up with 1 or 2 ideas about how to modify this question, maybe you could rank them in order. What's easiest, what's hardest? Because it's good to have a continuum of problems depending on what the student can handle. And also, just to be clear, so I spent a week in Louisiana about a year ago doing demonstration lessons in northern schools. And I use these techniques in whole classrooms, and the kids got really excited. So you can use these in tutoring or in whole classrooms. In fact, sometimes they're more effective in whole classrooms because the kids get excited together or in groups. So if you wouldn't mind jotting down a couple ideas about how to modify that question so it looks harder, but it's not really harder. You know, one example is you could change you could use 2 denominators that are different. So like a half plus a third, but that's not a small variation. That's a major variation. Because the kids would really have to know how to change the denominators. They'd have to understand equivalent fractions. So what we're looking for here is very small variations, just using what they know already. So maybe take a few minutes, and it would really help us if you type something in the chat, or if some of you feel comfortable even turning on your mics and saying, we'll take maybe 30 seconds to think about that. And then maybe people can start putting answers in the chat.
I know y'all have ideas on this.
Yeah. I'm having trouble seeing the chat, Lynn. So can you see? I don't know. I've lost my chat on here.
I can see it. If you extend your screen at the bottom, you'll see it come back.
Okay,
it
great.
Goes away if your screen's too minimized. You see it? But no one's saying anything now.
Okay.
I guess we're gonna have to call on somebody.
Yeah. So think about it. How could you make that look harder? What element of this? And you know, maybe it's maybe we should scaffold this more. So these fractions, you have the top number, the numerator. You know, with kids, with kids first learning this, I just say the top number before I use the word numerator. And you've got the bottom number, the number on the bottom, the 4. You know, how could you change those so that the problem looks harder? Or how could you add an element to the problem so that it would look harder?
Okay, sir. So,
Thank you.
hi, good evening, good afternoon. My name is
Hey, Myra.
And so, am I understanding you right? I'm thinking along the lines that these are raw numbers or naked numbers. So, if you turn it into a word problem where kids have to decipher and select the direct numbers, is that along the lines that we're thinking?
You
Is that
could,
instead
you
of
could,
giving them I'm sorry.
oh, thank you. Sorry, I didn't mean to cut you off. Yeah, so you could create a word problem, a simple word problem
Okay.
where they would apply this. That would be one thing you could do. You know, if you had a quarter of a pie and a quarter of a pie,
Yes,
or a fourth of a pie and a fourth, how much pie would you have?
yes, sir.
Now, now, one thing to think about when you create these questions is, are there any barriers to the student? Because you want, if you're trying to get them really excited, especially as a group, you want to make sure that no one's left out. So a word problem might be, you know, one of the more challenging things you give them. It would belong on this list, but that's something I might rank higher in difficulty because of the words. The kids might struggle with the words, but
However,
it's,
John, I think
yeah, yeah,
if you sometimes I think the context absolutely gives kids access to the math, because if it's something that they have an experience with, then they can connect it. So
yeah,
if you said something to the effect of, we had a peanut butter sandwich, mom had a peanut butter sandwich and split it up into 4 pieces, she gave one of those pieces to you and one of those pieces to your brother, then that really helps connect to something that everybody has had an experience doing before. So I
yeah.
love that idea of connecting to words whenever possible. For sure.
That, and that's a great idea. And I also, I guess you could do it orally where you read the problem to the student too, which would help.
Actually, I always tell my pre-service teachers that I understand during testing that students have to be able to read for themselves, but during your math class, we cannot let their difficulties in reading be a limit to the mathematical knowledge and understanding that they gain. So I suggest that in most cases, we always read to the kids if they need it, or let a peer read to them or something like that.
Yeah, that's a great point. Don't let anything be a barrier to the math. And so, Myra, thank you so much. That's a fantastic idea, and to connect it to the kids' experience is a really good idea to make a problem with that they understand. Um, Now, did anyone have any other suggestions about how you could take a question like that, like a quarter plus a quarter or a third plus a third, and make it look a little harder for the kids?
Karen wrote in the chat to ask the question, what's equivalent to 1/4 plus 1/4?
Okay, that's great too. You know, because a lot of kids will write 2/4, which is a good answer. It's the right answer, but that's also equivalent to a half. So you could give your students, that's a great idea. You could give your students questions where the answer is equivalent to another fraction, like a third, a 6 plus a 6 would give 2/6, which is equivalent to 1/3. So that's a great bonus question. Not only tell me the answer, but tell me what it's equivalent to. So
You
that's
know,
another
John,
one.
I'm sorry, I keep
Yes.
butting in. I
No,
also
no,
think
please
that
do.
also often think that it's really appropriate for kids to leave their answer as 2/4 in some
Yep.
cases, particularly in the example that we just gave, because the sandwiches were literally cut into 4 pieces.
Yeah,
So the answer was 2/4. Now,
that's
of
right.
course, an equivalent fraction to that is a half as well. But the answer to the actual problem, it was 2/4 based on that story that we wrote. So, and also someone wrote about improper fractions in the chat as well. So I thought I would talk about that right quick. Whenever we spend all this time, I think in elementary, particularly 5th and 6th grade, helping kids, change fractions from improper fractions to mixed numbers and things such as that. Whenever they get to algebra, we need improper fractions. And many times, and just like the example I just gave, many times an improper fraction is really a more realistic answer than the mixed number would be also. So I think we really need to spend a lot of time thinking about the context and what we're using the math or what the question's asking and how they answered. And I'm not saying by any means that they don't need to know equivalent fractions, and that they should also be able to discern that, oh, well, that 2/4 could have been just a half of a sandwich, but it's
Yep.
also connected. And I think that 2/4 is really just as great an answer.
Yeah, and to build on that point, it's really important to understand what the, you know, if I see a child who even makes a mistake, on a few questions, I'll mark the ones that are right first, or praise them for that first, because the minute they hear that's wrong, they've shut down, especially if they've struggled. And so it's really important to say, yes, 2/4 is in a lot of contexts is the best answer. It's important to understand where the student's coming from. So I think what I'm going to do now is I'm going to show you something that might look kind of trivial, but I've used it in a lot of classrooms to get the whole class going, and I'll show you some videos of this later. What I found for kids who are struggling, or for novice learners who are just starting to gain confidence, I found it's very effective to only vary a problem very, very slightly. So here's an example. Sorry, I'm just going to make sure I can. Here's an example that you might not think of. Just make the denominator bigger. That might not look harder to you as an adult, but kids, I guarantee they think that's harder. So I've even used this up to grade 5. And when you get into the thousands in the denominators, kids are literally pumping their hands in the air with excitement, saying they can answer that. And I purposely keep the top number 1, because I'm not sure all the kids, I'm doing demo lessons with kids I don't know. I'm not sure they can all add fluently. But I want them all to be able to participate on exactly the same level. I don't want any difference between the kids in the class, because once you eliminate the differences, their brains can work. So this might seem like a kind of dumb or trivial thing to do, but try it with your students. If they've learned a quarter plus a quarter, try and make the denominators bigger. You'll wake them up, and kids are pretty naive, even up to grade 6. They will often think that's a harder problem, and they'll think they're really great to show off and do that. So what I'm really encouraging you to do is, don't think like an adult, think like a kid. Kids like variation. Kids like small variations more than adults. Kids love repetition more than adults. Kids love playing with things until they get used to them. So play with this a bit, like give them a couple questions and make the denominators bigger and bigger. I was once teaching an autistic boy who would throw up at school. He was so anxious, and he was almost ready to give up on our lesson, but just by making the denominators bigger, he got so excited that he started to participate, just from that very simple thing. And I had to make the numerators 1, because he couldn't add fluently, but he could get this experience of meeting this challenge. So, there's a zone of productive struggle for kids, and their brains don't work if you don't keep them in the zone of productive struggle. If you push them outside it too far, they shut down. And so for some kids, that zone is very narrow, and this might be just the question you need. Just this small variation. Think of small variations. What can I change? The denominator. I could change the denominator. I could just make it bigger, and that will appear harder. Now, here are some other suggestions. You could add a third fraction on the end. Kids think that's a lot harder. Or a fourth one. Like literally, I've in behavioral classes, I go up to a kid and I say, I think that's too easy for you. Can you do 4 fractions? And suddenly the child who is misbehaving becomes an angel. I've had kids cheer in behavioral classes for this kind of approach. Here's another example. If they also understand subtraction of a fraction, you could throw in a minus sign and say, I'm going to trick you now. And the kids love it. And they say, I didn't fall for your trick. I noticed there's a different sign there. And that wakes them up too. Like for some kids, it's the first time they actually pay attention to the signs. They look at what's written on the page, they start to read the symbols, and they connect because they're meeting a challenge that they can handle. Here's another example. These are more and more advanced depending on what your student needs or your students need. But you could create a little algebraic puzzle where there's a number missing. And you could, one way kids would draw on their knowledge is by counting up. They might see, well, I've got 5. If I count up to 9 and keep track, some kids could even use their fingers. They could go 5, 6, 7, 8, 9, and they could see, oh, I need 4 more to make 9. So this is a great opportunity for kids to explore and connect things to what they know, to find the missing number. You could create an algebraic puzzle with subtraction. And so you see these are getting harder and harder. And this is where we could throw in some of the questions that the participants recommended, like a word problem, or or a problem where if they know equivalent fractions, where they have to change their answer to an equivalent fraction. And here's one, so suppose you have kids who are really flying. Here's one I used in a school in Brooklyn, sorry, in Manhattan. These kids, I don't know if you can see that. I used this with the kids who got the greatest gains on the state test scores. These kids were like flying and so excited about math. But when I put that up on the board, they said, that's not fair. You didn't explain to us how to add fractions with different denominators. And I said to the kids, well, you guys are so clever. Think about it for a bit. I'm not going to tell you. Struggle with it and think about it. Now, does anyone notice, are there any pairs of fractions here that might go together where you don't have to change the denominators? So maybe if you guys could put in the chat, or if someone would volunteer to put their mic on. Are there any question numbers there you could combine? This is a great question because it looks really hard to grade 4 kids. But if they're confident enough and you've created this continuum, it's important to get them there. So you want to create easier questions first to get them up there. But if you brought them to that level, they might be able to struggle more and try this one. Yes.
For this one, you would have to put terms of like denominators together first.
That's right.
And then in order to solve, you find a common denominator.
Yep. So you could rearrange these. So the ones with the same denominators, you said the like denominators, you could put 1/3 and 2/3 together because they have the same denominator. And what do you get with 1/3 and 2/3? You get 1. And then you could put a 1/4 with 3/4 because they have the same denominator. So you get another 1. And you could put the fifths together, the 1/5 and the last number 4/5. I'm sorry, I should have had something to write on this, but I hope you can see that you can put like terms together or like denominators together. So this is a great question for kids when they're ready to struggle. Now, so what I recommend is whatever you're teaching, think about, can I vary it? Can I make it look a little harder? And we're going to come back to this exercise and do it again later. So you have another chance to practice this. But I found I've taught hundreds and hundreds of classrooms, and as I said, I've taken many remedial students out into academic using these kind of methods. They're pretty foolproof and they work with whole classrooms. But when you're teaching, I'd recommend you always have a space on the board. You could call them bonus questions, and I'll show you some videos of this later. But always have a space to put up some bonus questions that are just a little harder, but aren't too hard. And if your kids can handle more, you can go up to the kind of question that's at the bottom. They have such a thrill at discovering, the solution. That's one of the great things about math, that there's a thrill of discovery. So Lynn, feel free to jump in here anytime and if you don't want to comment, that's fine too.
I'm good.
Okay, fantastic. Okay, so we want to look now at a lot of kids struggle because they don't have a lot of confidence about numbers, and to become a great problem solver, it's not enough to use your calculator, because if you use the calculator all the time, you'll never see a connection between the numbers. You'll never see a pattern or make a prediction or an estimate. You won't even know if the numbers coming out of the calculator are right. So it's extraordinarily important that kids learn to build a mathematical fluency. And we're going to look at some different things you could do there. And if you want to know more, just go to the JUMP website and go to the Introduction to the Teacher's Guides, and you'll find in every grade level, you find a section on mental math. So these are some samples. So here, now, if you wouldn't mind, again, taking a pen and pencil and really imagine you're a student. So I tried this exercise once in a grade 3 ICT class in Brooklyn, and I've used it in many classrooms. I put this pattern up on the board. It's the even numbers times 6. And I just asked the kids to look at this array and to tell me what patterns they saw. So if you guys wouldn't mind doing that, maybe you could jot down in the chat any patterns you see there. So you'll notice it's just the even numbers times 6. So spend a minute looking at that and see if you can see any patterns. And it would, again, really help us if you just turn your mic on and tell me any pattern you see. Or you could put it in the chat.
In the first column,
Ahead.
Yep.
you're counting by 2, and in the third column, you're counting by 12.
Excellent. Yeah. So that's quite sophisticated, noticing that you're going up by 12s over on the right-hand side. And so kids often see the pattern by 2s, but they don't always see the pattern by 12s. You know, some kids even like saying it's going up by 6s in the second column, or by 1s in the ones digit of your answer. It's going up 1, 2, 3, 4. So this is a great exercise because kids can contribute. You know, every child in that class saw some kind of pattern. And so that's a good warm up. But then I challenge them. So I have a challenge for you guys. Look across the rows. Don't just look down the columns, but look across the rows. Do you see any repetition of numbers in the rows? If, you know, 2 times 6 equals 12. Do you see any number repeated there? 4 times 6 equals 24. Do you see any repetition? And the kids see that, especially if you give them some hints. They see that the number you're multiplying by is the same as the ones digit of your answer. So you see the 2 times 6, you can see the 2 in the 12. And the 4 times 6, you can see the 4 repeated in the ones digit. So that's really, the kids get excited about that. They love patterns more than adults do. And it also helps them remember those facts, because, and they, sometimes I name the pattern after a kid. I'll say that's so-and-so's pattern. And then they really remember it because it's their discovery. So then they've got a way to remember these things that's exciting, that's connected to their experience. It's not just dull drills. They actually remember, oh, an even number times 6, you know, the ones digit. Now, what about the tens digit? That's a little more sophisticated. If can you guys see my cursor? If you look at the relationship between these two numbers, I hope you'll notice that if you double this number, if you double the tens, you get the ones. Or the ones are twice the tens. So here, 24, 2 doubled is 4, 36, 3 doubled is 6. So the ones are twice the size of the tens. And then kids have a way to remember this. They remember, oh, the ones digit is just what I'm multiplying by. So if I'm multiplying 6 by 8, I know the ones digit is 8. But then I know the tens digit is half of that, or one is double the other, so I know it's 4. And immediately they get 4 facts in 5 minutes. Like literally the kids discover these things in 5 minutes. Not only that, because multiplication commutes, the order doesn't matter. They actually get 8 facts. They don't just get 4 times 6, they get 6 times 4. So in 5 minutes, your kids can discover for themselves sort of 8 facts, and they can remember it because it's connected to that fun, that experience they had. Also, if you have kids who need extra work, you could say, keep extending this pattern, 10 times 6, 12 times 6. Look at what happens if you extend it. That's a great exploration. Or does it work for the odd numbers? Why doesn't it work? What kind of patterns do you get for the odd numbers? Those are great explorations. So this is a kind of isolated thing. It works for the 6 times table, but the kids love it, and it also helps them remember those 8 facts. And imagine if kids got this every day. Imagine you as a teacher inheriting a class in grade 4 or 5 where they know their times table. Imagine imagine how much easier your life would be if your kids knew their number facts, because that's one of the main reasons they struggle. So there are really fun ways to learn their number facts, which are in the Jump Math books. Are there any questions or comments on this before we go on? Now, there are patterns in all the times tables that we wrote up in the Jump book. So here's a beautiful one in the 8 times table. If you put the 8 times table in columns of 5, you see lots of patterns there. So maybe in the chat you could, or if anyone wants to turn on their mic, and it's been very helpful, all the comments you guys have made so far. Very, very helpful. So here's one thing that's important too, is to prompt your students and to guide their attention to help them see things. So look in the first column, 1 times 8, 2 times 8, 3 times 8. Look at the answers in the ones digit. You notice a pattern in the ones digit going down. So you see the ones digit goes 8, 6, 4, 2, 0. Now look at the next column, 6 times 8, 7 times 8, same pattern again, 8, 6, 4, 2, 0. The beautiful thing about the 8 times table is that this works forever. When you write 11 times 8, 12 times 8, 13 times 8, it still goes 8, 6, 4, 2, 0. The kids absolutely love that it goes on forever. Also look at the pattern in the ones digit. 1 times 8, the ones digit is really a 0. 2 times 8, the ones digit is a 1. It's always 1 less in that first column than what you're multiplying by. So those are little, cues that kids can use to remember these facts, and also to write it out. I find kids find it very easy to write out the 8 times table once you show them this. The only trick is that when you get to 5 times 8, you'll notice the tens digit is 4. That repeats in 6 times 8. There's a repetition. The tens digit is 4 again, 48. So that happens forever too. The ones digit always goes up by 1 as you move down the columns, but then it repeats every 5. Now, if I had a very advanced class, I would ask a question was like, does the number 128 appear anywhere in these charts? And if so, what row? You can make anything harder if you want. But as I've been saying today, it's important to start in the kids' zone of productive struggle. So this is a good zone for a lot of kids. They can see these patterns. So we're going to move on from this now, but there are patterns in every times table like this that you can make math a lot more fun and engaging if you get the kids to discover these things themselves. So here are some other strategies for learning, your facts or your operations. And Lynn suggested we do this, and I'm glad she did. And I think she's going to show a video in a minute. But one thing sorry, go ahead, Lynn.
Well, I think the patterns are absolutely intriguing for kids, and we know patterning is important and it's incredibly beautiful if you love to do that sort of thing. Another thing, though, that's pretty important is that kids learn to think relationally, which is what the examples in this slide actually show. So since most of you, we feel like the audience for this session is people who are doing some after school work, and I don't know, but I have a feeling a lot of that sometimes comes down to you hear teachers say, or parents or whomever that say, my kids don't know their facts, my kids don't know their facts. And so I think that probably that's an important issue that almost all of us are dealing with. And so I can sit over here and tell you that, not trying to be haughty or anything, but I have 3 degrees that are math centered, and I did not learn my multiplication facts by memory. So I feel like I'm, an Alcoholics Anonymous or whatever they say. My name is, and I am an alcoholic. I say my name is, and I don't know all my facts from memory. And so I think it's pretty interesting to find out that you can get by, but we don't want kids to just get by. We don't want them to feel the way that I felt or that some of you have suggested that you feel. We want them to be confident, and in order to do that, one thing that we know about the facts is that kids can use facts they know to figure out facts that they don't know. And so for just a second, I'd love to hear what anybody has to say about what does it even mean for a kid to be fluent in their facts? Like, what does that mean? What do they have to do to be considered fluent? And I'm going to use good wait time because I know you know the answer to this. For a student to be fluent, what are you looking for in their facts? Anybody? Okay, somebody wrote automaticity. Okay, so there's something to do with the speed, right? Everybody agrees. They have to have some sort of speed requirement. Now, guys, it depends on who you ask what that requirement is. Some people think it's three seconds per fact. Some people think it's 5. Some people think it depends on what grade they're in. There are all kinds of different opinions on that. But what else do they have to do besides being fast? Anybody? I'm looking in the chat, anxiously awaiting. My goodness, I've never had a group before that I didn't wait them out. Why am I feeling like telling you? I know you know this already. They have to be fast and they have to get the answer right. So accuracy and speed are what most of us consider important or to make a kid proficient. But we know that there's one other missing component. In the Common Core, when it came out, it really had a lot to do with not only speed and accuracy, but whenever the Common Core got written and then we changed over to the Louisiana standards, there was an added component, which was understanding. We wanted kids to understand what it meant, what these ideas were. In order for us to tell that, then they need to be able to compose and decompose numbers and put them back together in different ways. And they can use the facts they know to find the facts they don't. And so they might know some of those facts because of those patterns that we just talked about. Or some of them, y'all, we just remember some of them. Like there are just some that are easier than others. The square numbers tend to be easier than others. Of course, kids know their doubles pretty fast. They know the ones that end in 5. They know the 10s. So if they know their 2s, they can get their 4s. So there are a lot of facts that kids come to us with automatically. Do you want me to show the video now, John? Because it fits with this slide.
Okay, great.
So what I'm going to show you in just a second is this video. It's a kid that's a 3rd grader. I'm the interviewer, and I'm just asking him some naked number computation problems. This kid would be considered by our definition as not proficient. And the reason that he would be considered not proficient is because it takes him longer than 3 seconds in some cases. In some cases, it takes him longer than 5 seconds. But what I'd like for you to do is as you watch him say the answer, and he's doing this in most cases mentally. So I think it also fits with mental math because we want kids to be able to solve their facts mentally. So he solves mentally, but he engages with a lot of properties of operation. And so I'm just going to give you an example of what it could look like for a kid who's beginning to develop this automaticity, but he's just not quite there yet. However, there are an incredible number of properties of operation that he's playing around with in his head. He doesn't know that he's using the associative property or the distributive property or the commutative property, but all he knows is he's using facts to get other facts. So if children are not allowed to do this as a kid, if they're just given a fact sheet and said to memorize it, then we're robbing them of the opportunity to engage in these properties of operation at its most foundational level. So I feel extremely passionate about this idea, and particularly watching this child I think is going to help you see. So as you watch him, guys, the clip I may cut it short. It's about 4 minutes, but he's doing several. I want you to think about the math that he's doing that you see embedded in his strategy. So
so should I stop sharing?
You'll have to stop sharing yours.
Okay, there. Yep, here we go.
All right, so watch him. I'm going to say watch and learn, because we absolutely learn from kids all the time. Okay, Tanner, I'm going to ask you a couple of math facts, okay? And if you know it, you just tell me what you know. And if you don't, if you have to figure it out, you tell me how you figured it, okay? Okay, ready? What is 3 times 6?
18.
How'd you get it?
I did 6 plus 6 was 12, and And 12 plus 8 is 20, and it's not 8, it's 6, so I took 2 away, and that was equal to 18.
Okay, how about this one? 4 times 3.
12.
How about this one? 8 times 5.
40.
How'd you get that one?
I did 8 times 5. I knew that 10 times 5 was 50, and I just took 10 more away because 5 and 5 is 10, and that's 2 5s, so it equaled 40.
Okay, I see what you did. All right, what about this one? 5 times 7.
35.
Did you just know that one, or did you have to figure it out?
I kind of figured it, and I kind of just knew it because the last one was 40, and it was 8, and I just took 5 away because that was 1 less 5.
Okay, how about this one? 4 times 9.
Four times 9? 36.
Okay, how'd you get it?
I did 9 and 9 was 18, and 18 and 18 was 36.
All right, let's see what you can do with this one. 6 times 8.
$47.
How'd you get 47?
I knew I did. I started off with 6 times 6 was 36, and I added 6 more was 41, and I added 6 more was 47.
Okay, so you got 36 and you added 6 more and got 41. Can you show me how you did that?
Ten, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42,
So what was your answer?
48. My answer was 42, but then I added 6 more and got 48.
Okay. All right, let's just say one more of these. How about 9 times 8?
No, 72.
How'd you get it?
I did 9 times 9 was 81, and minus 9 was 72.
Okay, this one will be the last one.
What kind of comments do you have about that? What kind of properties did you see? Anybody? Now, usually someone speaks up about this kid. Nobody? Well, okay, guys. He absolutely was not fast. I get that, but it was all mental. And the properties of operation for which he engaged included distributive property of multiplication over addition. He had some associative property. It's not a property. He was able to decompose and recompose number. He was able to multiply up and subtract back off. He was able to use doubling. There were just tons of different mathematical relationships that he used to get those pretty difficult ones. And so, like on the 8 times 5, for example, he starts with 10 times 5. Well, who does that? I don't know, but he did. And it's really hard, I think, as a teacher sometimes to listen to that and go, wait, hold on just a minute. What did you say? Because I asked you 8 times 5. And he said 10 times 5 is 40, but it's not 10 times 5. It was 2 less 5s. So I just took, and I get that it's kind of hard to listen to. He said, so I just took those 2 5s away. That's 10, so it's 40. So we have to get good at listening to what they say and figuring out, wait, does that work every time? And if it does, how can I prove that? I wouldn't ask him to say what properties he used or anything like that, but these mathematical ideas show me a whole lot and give me tons of insight about his knowledge and understanding.
Yeah, that's fantastic. That was so interesting. So if we go back to this example here, you said he used a distributive property. So here's an example where you can turn 3 times 6 into an easier multiplication. It could be 3 times 5 plus 1 more 3. And it's really easy to show kids this with an array. They sometimes don't understand the distributive property when it's done like it is in the first row, but when you show them an array of dots, they can see 3 6s is the same as 3 6s is the same as 6 3s, which you see in the array. 6 rows of 3 is the same as 5 rows of 3 plus 1 more 3. And so there's lots of, yep.
I'm sorry. I would want, like I gave Tanner 3 times 6 as well. And he did it in a totally different way. He said 6 plus 6 is 12 and 12 plus 8 is 20. So I would love for these two kids to get together and compare how they solved and say, okay, well, where was the 6 in yours? And, why did you use 5? And talk to each other about it. Or I could lead that discussion as a teacher, because either one of those strategies is totally appropriate. They just use some different ideas. I want them to be flexible and use any of those. And I see that 5 plus 1, breaking that 6 up into a 5 and 1 is really common, and it's a really great strategy too.
Yeah, and once they see that the 1 more, they they can do 6 times 8 is the same as 5 times 8 plus 1 more. So there's other, I'm going to move through, they can use doubling. So if, for instance, if they know 2 times 7 is 14, then they also know 4 times 7. So I'll say to kids, if you know 2 times 7 and 3 times 7, you know 2 other facts. Because if you double the number you're multiplying by, you also double your answer. And those are easy doubles that they can do mentally. I was once working with an autistic boy who had a horrible time. He was diagnosed as being the 0.1 percentile, and he had a horrible time. He was so anxious remembering math. And one day I realized he knew all the names in Harry Potter, the Weasley twins and so on. So I played the Go Fish game, but I modified the rules. I gave him a chart with the numbers that add to 10, 1 and 9, 2 and 8, and so on. And I said they're magic twins because of the Weasley twins. And we played the game Go Fish, but I changed the rules. So if he had a 1, he could ask for 9. If he had the ace, he could ask for 9. If he had a 2, he could ask for an 8, and so on. And in very few games, he memorized these. He just learned them from playing the game because he was so excited to play the game. And then he could do things that cashiers can't do. He could go to the store with money and do mental math, because if he had 28 cents, he knew he needed 2 cents to go up to 30, because 8 and 2 make a 10. So I would give him exercises like this where he would fill in the missing numbers. 28, you need a 2. That's what would go up in the circle there to get to 30. And then 3 and 7 go together, and he'd need a 70 to get to 100. So he developed this mental fluency very, very quickly. And that gave him huge confidence that he could actually do something with money. Want to look at now scaffolding and how you can break challenges into more incremental challenges. This is a typical problem on a state test. And in this case, it came from a Canadian test, but it's a fairly challenging for grade 3 or 4 kids. For many reasons. They have to find the missing bar. You know, there's 30 students in total, and the bar graph shows you how many students like each color. You have to find the red bar. So if you could think about how could you scaffold that? Where would you start if a child is overwhelmed by this problem? How could you break it into smaller problems so that they could, you know, succeed with this? So one place you might start is the scale. There's numbers missing on the scale. And I always think about what numbers I'm going to use. Most kids know how to skip count by 2s and 5s. So I would play with scales that have those numbers first. And when you leave numbers out on the scale, that can be challenging for kids depending on where you leave them out. So on the right-hand side, 10 and 4 is particularly challenging for kids if that's where you started. Many kids will subtract 10 and 4 and get 6, and then they'll divide by 2 because there's 2 missing numbers, but you actually have to divide by 3 because there's 3 steps. So this page just shows again, this continuum of harder and harder problems that you could give kids to build their confidence, starting with fairly easy scales until they can read the scale. But the research in cognitive science is saying overwhelmingly that we cause cognitive overload in kids constantly when we teach them. We don't isolate what they need to learn and let them play with small variations. We don't give them enough practice. You know, I think you saw that in that video. If you allow the child time to think and to draw on what they know and to experiment and so on, that they can develop this real fluency and understanding. And it's the same in these problems. There's 3 components here. You have a part-whole problem where you've got the bars, and they have to be able to subtract the amounts they know from 30. So you've got a part-whole problem. You've got a scale problem, and then there's another problem if you actually do the question. Some of the bars that are halfway between the scale marks. So kids have to learn how to read the bars that are halfway between the scale marks. So what I'd recommend is when your students are facing these complex problems, see if you can scaffold them and break them apart into a series of simpler problems. Let them master each of those and then consolidate with the entire problem. So this is actually a picture of that class in Manhattan that I mentioned. These kids got the greatest gains on the state test scores and wouldn't stop doing math. And one of the ways the teacher got this to happen, and you can see the group energy. I want to do another exercise on confidence building and scaffolding. And sometimes with kids, if they don't know how to add fluently and I want them to do something with patterns, I'll give them permission to add on their fingers. So 16 plus 3, you could say 16 with your fist closed, whatever the number is, and then count up 16, 17, 18, 19. It's important that they tuck their thumb in. One teacher in England told me once that he would throw numbers to the kids. So he would throw the 16 at the kids and have them grab it. So they would remember to put their thumbs in. And then he'd just throw them bigger and bigger numbers. They weren't even adding, but they loved catching bigger and bigger numbers. We had a note from a principal at a first American Indian school in upstate New York, when the teachers tried this in grade 1, throwing the numbers to the kids, he said the kids literally were yelling to go up into the thousands because they wanted to catch bigger and bigger numbers. So you can teach kids to add and subtract on their fingers. For subtraction, they could say the smaller number, 8, and count up 8, 9, 10, 11. The number of fingers they have up is the answer. So that teacher I showed you who shifted the bell curve in grade 5, the one who was reported in the New York Times, this is where she started. This is what the first exercises looked like in the book she used. The kids just had to find the gaps in the sequence. So you see the first question there, 1A, you have 2, 5, 8. They just had to count the difference and find the gap. So they would say 2, 3, 4, 5. The gap is 3. 5, 6, 7, 8. So every child could participate. And then they could extend the patterns again by counting on. So here's another thing you could think about. What if you had kids who are finishing early? They're they're racing ahead, finishing this. How could you create some bonus questions for them? So here's one suggestion. You can leave numbers out in different places. The first question is quite easy because they can see the difference between 10 and 3. But problem, because one of the things you need to do as a problem solver is see where I have information that I can use. So this draws their attention to the importance of that. They can see, oh, 10 and 13, I can find the gap. The next problem is much harder. They have to guess and check or draw a number line, because all they have is they have to find a number halfway between those where the gap is the same. And then the third problem is much harder. This is one where they tend to subtract and divide by 2, where they really need to divide by 3. So you can create a sequence of problems like that for your kids. You can make the numbers bigger. You could add zeros. You could make a mistake and let kids correct it. There are all kinds of ways you can create simple problems, simple extensions of the problems to give yourself time to work with all your students. You could even change the gap between the numbers. So the first pattern, the first pattern has the same gap. It's always 5. You're going up by 5s, but you could say, do you see any other patterns? So you'll notice there's a repetition in the ones digits. If you write this out long enough, you see there's a repetition in the tens. The tens digit always go 1, 1, 2, 2, 3, 3. And the ones digits cycle between 2 and 7. And that always happens if you add by 5. So that's an exploration you could give students. What happens when you add 5 over and over? Do you always see the same thing? Yeah, you see the same repetitions. The next problem, the gap actually changes. 4, 6, 9, 13, you'll see the gap is increasing, and kids love that kind of problem. And the last question is the Fibonacci sequence. It's a very famous sequence in mathematics. It appears everywhere in nature, and it's a strange sequence, because if you look at any number, so look at the number 8, and then look at the 2 numbers before it, 5 and 3. If you add up 5 and 3, you get 8. And it's the same with 13. If you add the 2 numbers before 13, you get, if you add up 8 and 5, you get 13. However, a lot of people don't know that there's an interesting pattern in the differences in the Fibonacci sequence. So look at the differences between the numbers in that sequence. Kids are astonished to find that it's the same as the Fibonacci sequence. You get the same sequence in the differences, and they absolutely love that. So that's a beautiful pattern where the kids can calculate the difference and see how to continue it. Now, if I wanted a super bonus question, I would say, can you find a pattern that has the same properties, where the gap is the same as the pattern? That would slow down a faster kid and give you time to work with kids who need a bit of help. And when I say faster, I just mean initially. And fast isn't being fast isn't a virtue. It's just that some kids will need extra work. And what we found is when you equalize the classroom and let everybody succeed, then everybody speeds up and engages more. So in the study with Mary Jane, you saw that all the kids did the same within a year. So a great question here is, can you find a sequence that has the same property? And the doubling numbers have that property. 1, 2, 4, 8, 16. The gap between the numbers is the same as the sequence. The gap is 1, 2, 4, 16. So I just wanted to show you how a very simple problem, let's go back to the initial, a very, very simple problem that kids can do on their fingers can lead to all these more complex problems and get kids excited. So when I did this, I once worked in a behavioral class in Brixton in England, and a lot of the teachers thought the kids were unteachable. They were so unruly, grade 6 kids. On the third lesson like this, we did this with the kids. On the third lesson like this, when we came in, they cheered. The kids were so excited about discovering these patterns, at meeting these challenges. And so math is a really magical tool for social justice, to help kids who have struggled or felt alienated at school feel like geniuses, feel like they could do anything. And this is the secret: raise the bar incrementally, keep them in the zone. So, if the first question is working for your kids, give them more like this, make the numbers a little bigger. When they've got that, give them another variation like this where the gap changes. but always keep them in a zone of confidence. So these are some of the strategies you can use. You can vary the problem slightly. You can make a mistake and ask kids to correct it. I make mistakes all the time. That's foolproof. If you put up a question and you tell their kids there's a mistake, they love finding your mistake. You can
Just like to get bonus points. If you can find my mistake, you get bonus.
Yeah. So I recommend you always have space for bonus questions. Always be writing spontaneously on the board these bonus questions. You can challenge them to identify patterns, like in the last, the patterns changing, or in the Fibonacci sequence, the pattern's the same as the sequence. You can ask them to make up a problem and share it with another student. And that includes word problems. One of the participants suggested earlier word problems. You can leave out an element and ask what's missing. So I want to put it all together now with algebra. I actually, in Louisiana, I taught this lesson a couple times. You take a couple of tables, you take two tables and you put a bag on one and some blocks. So you can see on the left, there's a bag and some blocks, and there's blocks on the other table. And you say to the kids, there's the same number of blocks on each table. What's in the bag? And that's a great discussion point. Well, the kids will say there's 2 in the bag. There's 2 hidden in the bag because there's 5 altogether on each table. And it's a great discussion point with the kids because you can say, how did you find your answer? And some kids will say, well, I counted up from 3. Some kids would say I subtracted, and some kids just drew a picture. And then gradually, as you give these problems, you can go to the board and draw a more abstract image. So you could draw a square and some circles. And the kids could draw the missing circles. And then gradually, by the end of the lesson, you could move to numbers where they're actually writing numbers in. So I've done this lesson at least 20 times with grade 4, 3, 4, 5, 6 classes, and they absolutely love it. Start with the bags and blocks. They also love it when you use 2 bags. So for example, you might put 2 bags on a table plus 1 more. Here, I'll actually draw it. I hope you can see my screen here. So if you imagine putting 2 bags on one table and 1 block, and then 5 blocks on the other table. I don't know. The light's not very good. There. Oh, there. Can you see that okay? So on one table, you have 2 bags and 1 block. The other, you've got 5 bags. And you tell the kids there's the same number of bags. There's the same number of blocks in each bag. And they'll draw it. They could draw a sketch of this and count up. And they could use counters. But I found in every class the kids got this. And then they loved going up to multiple bags. Like I'd put 3 bags in one. They absolutely love this. So this is a way even to make algebra interesting, to connect it to a game, to connect it to their experience, and move slowly up to the more abstract model. I found that in that second step where you see in the second row there, where I draw on the board a box and some circles, I say, I'm going to draw the box on the board to represent the bag and the circles represent the blocks. I find it's really helpful if the kids actually draw the blocks into the bag before you move to numbers. It's really important that they actually draw it first, or the lesson doesn't work as well. So even algebra, so we've tried to show you through this how you can connect mental math, patterns, all these things. You can create a sequence of exercises that are connected to kids' experience, that are in the zone of productive struggle, and they get incrementally harder so that they can really feel they can meet any kind of challenge. And I want to show you quickly a video just of what this looks like. This is a grade 2 class. These are only grade 2, and I realize kids don't go very far in grade 2. They're not reading numbers in very big numbers, but I challenge these kids to read numbers beyond 1,000. So you can see how this went. Who thinks they could do that? You just have to say that number. You guys all can read that number, right? You try.
429, 1,237.
You did it. Fantastic. Okay, one last chance, and then we have to go to the millions. Okay? Yeah? Okay, here's your last chance for this one. Who thinks they could do that? Now, how about someone who hasn't had a turn yet? I know some of you may not. Yep.
231,000.
Yeah?
237.
Oh, amazing. Okay, who thinks they could go to the millions?
Okay.
Okay, now it's just the same game. You say that number and say million. Then you say that number and say thousand. Then you say that number. Huge number. Who thinks they could read it? Yeah? Do you want to help me? You get me started.
665 million.
Yeah, 625 million, that's right.
231,237.
Unbelievable. That is a big number. Who else thinks they could do that?
Oh yeah.
Yeah? Okay.
425.
Unbelievable. Okay, like I really wasn't planning to do this, but I think we have to go up to billions. The next is billions.
So easy.
All right, this is the last one. Okay. Okay, you help me with this one, all right? Okay, that was a big number. You want to help me? What's that number? Just say that for me. You get me started. Oh my God, you did it. Then what's this one? See, you did it. That's fantastic. Okay, I give up, you guys. I can't really make it any harder. I could go to trillions. And then quadrillions. Yeah. So, that just gives you an idea of how excited kids can get when you raise the bar like that. So I think we're pretty much out of time. I hope this has been helpful for people. It's too bad we can't be in the room and connect with you. We'd love to see you in person. But if you want to look at any of these resources we looked at today, just go to the Jump Math website. You'll find lots of free resources, especially if you do it in the next few weeks or so. I think we're moving to a new website, but right now everything is up for free, all the teachers' guides.
And John, if I can just remind everyone that this session is recorded and will be on the conference website, and we will upload it also to our network YouTube channel. And we will also be working to try to put together a session in the fall to kind of follow up when 21st century programs start to get into their planning phases for the new RFP.
Yeah, we really appreciate your participation, and it's a shame we can't be there in person, but it's been great working with you today. And thank you, Lynn, so much. It was a real honor having you join us today.
I loved it. Thank you so much for having me.
Yeah, and I hope you guys all have a great weekend.
Bye, everybody.
Bye, everyone.